All right, so we're sort of moving into a different type of discussion now. And we're starting to cover more information. And I was saying in one of the groups, if you find that some of this information from the videos after watching it is still confusing, I can go over it in this setting. You can also come to office hours or set up another time to meet, and I will go through the nitty-gritty with you. I find the digestive tract fascinating, hint, hint, therefore you must find it fascinating as well. So let me try to share my enthusiasm for the gut with you, and let me know what I can do to do that, okay? All right, so let's go to the question. So group one, what was your question and what brilliance did you come up with? Who's your speaker? Is group one back? Allie? No, that's group two. Georgia? HV? Katie? Are you not here? Maybe they're not ready. Okay, well then let's go on to group two.
Yeah, that's us.
Okay.
Our question was about if someone's having their gallbladder removed, what advice would you give them? Or what nutrition advice would you give them? Why and what nutrient would be affected the most? So we talked about the gallbladder stores and releases bile to break down fatty foods. So we would recommend avoiding like fatty, fried, greasy foods, at least at first, because as you said, Professor, your body like actually will adjust and the liver will like learn how to produce the bile to break down fatty food. But that just takes some time. So at first you'd want to avoid eating too much. We also found that you should gradually increase fruits and vegetables or other fibers because it helps improve digestion in the absence of bile. And then we also said to eat smaller, more frequent meals, again at first, so the body can use the available bile that it has.
Okay. So does anyone know anybody who's ever had their gallbladder removed? Yeah? How are they doing? Allie?
Good. They're like pretty much fine right now. It's one of my roommates actually had her gallbladder removed. It was our freshman year, and now we're seniors, and she's fine. She eats pretty normal.
And that's because over time, because our bodies are amazing, the liver will compensate. The liver knows what the gallbladder was doing. I don't mean to anthropomorphize body organs, but yeah, right. So Alejandra, did you say you knew somebody who had a gallbladder operation?
My mom, when she eats too much fats, healthy fats, because she's super healthy,
oh no.
She just gets like high cholesterol. Like if she eats too much nuts or avocado or meat, I don't know, she just gets high cholesterol.
Oh, so that's interesting because the type of fatty acids in those foods is unsaturated, or, you know, it's monounsaturated. And so those are supposed to be the heart healthy kinds of fats. Does she have any digestive issues or any discomfort? You don't have to tell me. I thought you were going to say when she eats a lot of fat, she still has discomfort because she, you know, there might still be some issues, but that's not the concern. Okay.
Professor, I was in group one. I just didn't realize it was group one, so I can go for us if you want.
Oh yeah, go.
So our question was, what is involved in the mechanical digestion of nutrients? So we said mechanical digestion is the chewing and breaking down of bigger foods into smaller ones, and it's also called mastication. And then the two ways that this is done is either through churning or segmentation. And so churning is when the stomach lining contains muscles and they physically squeeze and mix the food with the digestive juices. And then segmentation involves the contraction and relaxation of non-adjacent segments of circular smooth muscles in the intestines.
Okay, so if this kind of information ever appears in, say an exam kind of situation, you must use your own words. I want you all to own this stuff, Okay, no, this is fine for now. This is absolutely fine. So there are two types of digestion, and mechanical digestion is the physical digestion. Mastication is what occurs in the mouth. It's the chewing, and then we have the swallowing, and then we have the churning that goes on in the stomach, right? And your stomach is probably one of the strongest organs in your body. If you've ever had a really bad stomach virus, or, you know, you were puking your guts out for whatever reason, your stomach might hurt for another day or two afterwards, because those muscles are strained. They're really strong. So we have peristalsis that moves the contents, preferably with gravity, you know, through the body. We have segmentation that breaks it up into smaller and smaller particles, increasing the surface area for the enzymes. We have, what else did you have? Churning. We also have emulsification, is a kind of mechanical digestion as well. So we have mechanical and we have chemical, and these are the kind. Okay, group 3. You had to put on your dietitian hat that you were just given for this question.
That was us. So we talked about cystic fibrosis, which is when you have a pancreatic insufficiency. And usually they take digestive enzymes to help them absorb nutrients. And without those enzymes to break down food, they can't absorb protein, fat, and carbohydrates. So this leads to malabsorption. And so symptoms of malabsorption are like poor weight gain despite having good appetite, frequent or large bowel movements, foul smelling, mucus or oil in bowel movements, and excessive gas or stomachache or bloating. So they take these enzymes to help with all those symptoms.
Right. So folks who have cystic fibrosis, for whatever, it's a genetic condition and it's, well, anyway, we don't talk about that here, but yeah, they are producing excess mucus, their pancreas isn't working properly. And so they can't digest food in the absence of these enzymes. I mean, we have all these secretions that our body is producing. And so they need to take enzymes, and they take oral. They take them as medication, but they're what's called enteric coated, meaning that they're covered with a coating. And why would that be important? I think we might have brought this up in the last class with the idea. I think somebody's current event was Marissa, was it you who takes a supplement for your, anyway.
Yeah, it was me.
All right. So why should they be having enteric coated enzymes? And why should you, if you feel you need to take an enzyme? Do you remember? You can say no, it's all right.
Oh, are you talking to me?
Yeah, I know.
I don't really remember, to be quite honest.
That's all right. Enteric means coated, means that it is covered with a substance that prevents the acid from breaking down the enzyme. Protein digestion begins in the stomach. Enzymes are protein. Ergo, enzymes begin to get broken down in the stomach. So unless those enzymes are protected from the acid, they are useless in terms of doing anything. So folks who are on this medication are taking enteric coated enzymes. So that's what that's about. I just looked at my notes here, and somebody in their current event used the word may as part of a study, when you were reading the results. I just need to, whenever you hear the word may, also remember may not. All right. Because that's what we have to try to remember. This may cause cancer. It may not cause cancer. Okay, so I just threw that in there because I just saw it in my notes. I'll try to remember better next time. Okay, group 4. Who's your spokesperson?
Me, it's me.
Speak.
So our question was, we discussed how celiac disease affects nutrient absorption. After viewing the videos on the digestive tract, including digestive enzymes and secretions, describe again what is happening and why. So with celiac disease, we know that the body has an allergic reaction to gluten. Okay.
Okay, so I'm putting
another word
here. Please don't use the word allergic. It's not,
okay.
Celiac is not a food allergy.
Okay.
It's a non-allergic physiologic reaction.
Okay.
There you go.
And then that damages the villi, which are the finger-like protrusions lining the small intestine.
Uh-huh.
And then the villi surface area is then decreased. And so the body isn't able to absorb as many nutrients. And with that, which we discussed with you, Professor, but with the decreased surface area, there are less enzymes also being produced.
Right. Right. So the type of reaction that's occurring is an inflammatory reaction, but it's not a histamine release. That's why it's not a food allergy. Allergies involve IgE and histamine. This is an autoimmune disease, which means that the body looks at this gluten as not belonging there and mounts a reaction to it. And it destroys the villi and microvilli in response. So, yeah. Okay, thank you. Group 5. Made a lot of corrections here. I don't know how you edit these things. I've never played with this before. I love it. But group 5, what do you have for us? Who's your speaker?
Hi, me.
Hi.
So one of our first questions were, what is the difference between protein digestions and carbohydrate digestions?
Mm-hmm.
So, sorry.
Never
So
make the
protein
answers harder. Okay, never make things harder for yourself. So that's just, I'm throwing that out there. So let me see what you come up with.
Okay, so protein digestion starts in the stomach, where the HCI disintegrates the protein, and then the pepsin turns the amino acids strands into polypeptides, tripeptides, and dipeptides. Later, in the small intestine, the proteases, which are the protein enzymes, turn what is remaining of the protein into single amino acids that are absorbed by the bloodstream.
Okay. And how does
and that's different from the carbohydrate digestion, because carbohydrate digestion starts in the mouth, where with the salivary amylase, and then in the stomach, the carbohydrate digestion passes, and it starts again in the small intestine, where it is converted into 3 amylases, which are maltase, sucrase, and lactase.
Okay. Wow, I gave you a lot of things to answer.
Yes.
I get carried away. Would you like me to answer the other ones for you?
Yes, I didn't answer those. It was my other group member.
Okay, does somebody
Yeah,
else?
I answered the question about like lactose intolerance.
Okay.
And so lactose intolerance occurs when the small intestine does not produce enough of an enzyme, lactase, to digest the milk sugar that we talked about in a previous module, lactose.
Mhm.
And so when lactase turns milk sugar into glucose and galactose, these are both absorbed into the bloodstream and like through the microvilli and the intestinal lining. And lactase breaks down the lactose in your food so that your body can absorb it. But people who are lactose intolerant usually have really unpleasant symptoms if they do, yeah, like for lack of a better term, after eating or drinking milk or milk products. And some of these symptoms include like bloating, diarrhea, gas, but lactose intolerance is not the same thing as having a food allergy to milk.
Right. Okay, so let me just kind of summarize some of this. So with lactose intolerance, just as the body, when the end products of digestion, right? Carbohydrates are ultimately broken down into monosaccharides. Proteins are ultimately broken down into amino acids. Fat's more complicated, and we'll talk about that next week, or yeah. And it's these single unit amino acids and monosaccharides. They're small enough that they can then move from the intestine into the bloodstream. So that's the purpose of digestion, is to take my 1 bar and coffee and milk that forms a bolus, then forms chyme, then enzymatically and mechanically break it down into single units that are then small enough to cross into my bloodstream. Otherwise, my body doesn't benefit. I benefit because it tasted great, but my body can't use them. So when lactose, it's a disaccharide, if it's not being broken down into monosaccharides, it's too big to move into the bloodstream. So it moves into the large intestine and pulls water, and that's what causes the discomfort. So yeah, that's what that's about. And you did a lot of good detail on the difference between carbohydrate and protein. And what I would just say is, mechanical digestion of all of these are occurring, but chemical digestion of carb begins in the mouth, chemical digestion of protein begins in the stomach. They have different name enzymes. I think you were asking proteases for the proteins, amylases for the carbohydrates. So, okay. And last but not least, why does let me just ask, for group 5, are you going to neaten this up at all for the document if other people want to look at it, or am I just looking at, I've never done this. So does it get to look better, or do you?
Oh, is ours the one with all the lines?
Yeah, I think you have to like accept those edits because it's on suggesting mode. It's not on editing mode.
Yeah, it wasn't intentional on our
every
part.
day.
It just
So
keeps showing up.
Oh, okay. I have to share it. Oh man. So what, excuse me a second, folks. I'll be right with you. So what am I doing when I?
Maybe just go on sharing mode and then press edit. I think you might have put us in a different.
Let's see. Anyone on the internet can comment. So I want to say edit.
Yes.
Okay. Thank you. I love this. Where has this been all my life? Anyway, question number 6, group number 6. What can you tell me about the pausing of carbohydrate digestion? Who's your designated speaker? Jackie, Kevin, Kyle?
Yeah, I don't think we designated one, but I can take it over.
All right.
So carbohydrate digestion pauses in the stomach because the salivary amylase, which is the digestive enzyme for carbohydrates, is inactive in the stomach due to its acidity, as we talked about before. So these carbs are actually broken down in the small intestine, which is why they're quote unquote put on pause. So in the stomach, an enzyme called pepsinogen, which is activated, which then becomes pepsin, that is secreted by the stomach wall. And then once that chyme is expelled into the upper part of the small intestine, as I said before, these carbohydrates are then broken down into smaller singular units that can be transported into the inside of the intestinal cells for absorption.
Okay, great. And all of these monosaccharides go to the liver. And when you look at that discovery video, I think that the liver, where over 500 functions occur, they're all, for our purposes, converted to glucose. Fructose gets converted to glucose. Galactose gets converted to glucose. And that's why glucose is known as blood sugar, because everything gets converted to glucose in the liver. All right. That was a lot. That was very good. Thank you. What I want to do before we go is I just want to, because I didn't get to do it in the classroom, do my spiel about digestion. All right. I'm just going to go through it and it'll be recorded. So we have digestion. We have mechanical digestion and we have chemical digestion. In the mouth, the chemical digestion of carbohydrate begins with the action of salivary amylase on carbohydrates. You can try this at home for yourself. If you take a cracker and you put it in your mouth, you just chew it a little and you let it sit there. This is not an assignment I would say to my class to hand in. Nobody ever thought it was funny. Obviously, I still do. So you chew it and it just sits there, and some of you may notice a change in the taste because what's happening is the starch with the action of salivary amylase is starting to get broken down into smaller saccharides, and some of those may be sweeter. So then we have this bolus that crosses over the epiglottis, goes down the esophagus, crosses over the cardiac sphincter, and enters the stomach. In the stomach, carbohydrate digestion pauses, as was so eloquently explained, because the amylase enzyme is itself being denatured by the acid and the pepsinogen in the stomach. With the mechanical digestion of the churning, as was described in another group, all of these could then form a semi-liquid mass of partially digested food known as chyme. The chyme crosses over the pyloric sphincter. Right? Sphincters are valves that link the different organs together. It crosses over the pyloric sphincter and then enters the small intestine. As the chyme is crossing over the pyloric sphincter into the small intestine, we have the gallbladder getting a message to secrete bile into the chyme to begin to emulsify fat. We also have the pancreas secreting bicarbonate to neutralize this low pH or acidic chyme. All right, and then we have other pancreatic enzymes. As the contents move through the small intestine, we have enzymes from the pancreas and the intestine, amylases breaking down the carbs, proteases breaking down proteins, lipases breaking down lipids to their smallest component parts. And those small component parts, which we'll talk more about on Monday, are then absorbed into the circulatory system. That which does not get digested and absorbed, and fiber is one of the things that does not get digested and absorbed because we don't have enzymes to break down beta-linked glucose molecules, crosses over the ileocecal valve into the large intestine. In the large intestine, the contents, if the body needs water, it will take water from the contents of the large intestine back into the body, and whatever is left over will be stored in the rectum and ultimately gets excreted. And I think that's as good a place as any to end. Any questions? That's the digestive system. My favorite. That and the immune response system, but for here it's digestion. Okay, so let's see. I will.
Just to reconfirm, oh, sorry.
No, please.
There's a second set of videos on that page, or module in Canvas. That's for the next class, right?
Right, we'll talk about
So
fat digestion and absorption, which is more involved because fat is hydrophobic and we need fat to somehow get into the bloodstream. All right, so it's processed differently. And then there is the video that I would show in class, but you can watch it on your own. And it kind of explains the GI tract. I do want to give you a heads up. Some of it is kind of graphic. You get to see the semi-liquid mass of partially digested food because that's fun. I usually just show it up till the tennis scene because I don't go into the bladder, but you can, well, you'll do whatever you want. And then I've recorded digestive issues because that's always interesting to discuss. So if you know folks that have ulcers or colitis or any of that stuff, do share. And yeah, we'll finish that discussion. And whoever has current events, and if you have any questions you want to add to the Padlet, and if you're observing Rosh Hashanah, Chag Sameach, have some honey, and you go now. Any other questions? All right, thank you.
Thank you, Professor.
Thank you.
All right.
Thank you,
Thank you.
Professor.